Lesson 6.3, Vectors. A mathematical vector is a directed line segment, and we write it as a letter with a little right harpoon over the top. Has direction and magnitude. Often in textbooks they'll just use the letters, but they'll make them bold. So bold V would be vector V. Has direction and magnitude. The magnitude has these double absolute value around it to show magnitude. That's the length of the segment, and the direction is, well, the direction of the segment. The arrow shows the direction. Component form looks kind of like a point, only we have these angle brackets, and it's V1, V2. So this is the x component and the y component. So it's how far it goes in the x, how far it goes in the y. So if we look at this one in the picture, we go 3 in the x and 2 in the y. So the one in the picture would be 3, 2. To calculate it, you take your second point and subtract the initial point. So if this was Q1, Q2, and we started at P1, P2, our vector is Q1 minus P1, comma Q2 minus P2, which gives you V1, V2, with a comma in between. The magnitude is the length, so it's really just the distance formula. So the magnitude is the distance formula, and I have it with the points or just the components of the vector. So let's find the component form of a vector and its magnitude if its initial point is 1, 7. So this would be like P1, P2. And its terminal point is 4, 3, so it would be Q1 and Q2. The vector is found by taking your final point, your terminal point, subtracting the initial point. So it would be 4 minus 1 and 3 minus 7. So that would be 3, negative 4. The magnitude, it's the square root of the x component squared plus the y component squared. It's 9 and 16, or 25. So the magnitude of this vector is 5. The point of vectors is we can do operations with them. So the simplest one is scalar multiplication. Scalar multiplication is like multiplying a vector by 3. So if I have vector v and I want to multiply it by 3, it'd be like having 3 vector v's all in a row. So that is simply multiplying each component by the k. Where if k is negative, it would go in the opposite direction. So if you multiply by a negative number, it flips around, goes in the opposite direction. To add vectors, graphically, you would draw the first vector, and then you draw the second vector at the end of the first vector. So you have vector v, its arrow, then you draw vector u with its arrow, and then the sum, we call it r for resultant, goes from the very beginning to the very end. Well, it turns out that if we just add the corresponding components, we end up with the same thing as the drawing. So let's add 2, 3 plus 1, 0. So it's simply just add like terms. So it would be 2 plus 1 and 3 plus 0. which gives me 3, 3. Let's let vector u be 1, 6, and vector v be negative 4, 2. Find 3u. All right, well, 3u would be 3 times vector u. So that would be 3 times 1, 3 times 6. I have the graph here so we can kind of show it. So let's say we started here, and I went up 1 and over 6. So that would be vector u, and if I want 3 of them, I'd have 3 of them in one long line, which means I'd be going up 3 and over 18. All right, we have 2v, so 2 times v plus u. So let's start by multiplying. Order of operations still applies. So then I have negative 8 plus 1 and 4 plus 6. All right. So let's say I start here and I go to, actually let's start right here. Let's say I go down 4 over 2. So that's my first vector v. So that's v. And then from there I go down 4 and over 2 again. So there's my second vector v. So that's my 2 v's. And then I need a u. So I go up 1 and over 6. So that is my vector u. So my result goes from the beginning to the end, right there, which is down 7 and over 10. Hence, I got negative 7, 10. A unit vector is a vector in the same direction, but with a magnitude of 1. So its length is 1 unit. And so what we do is you just take your vector and divide it by its magnitude. So if you take the whole thing, divide it by its length is now 1. There are special unit vectors, I, which is 1, 0, and j, which is 0, 1. So this is like x and this is like y. I is 1 unit in the x, j is 1 unit in the y. So we have what's called linear combination form. So instead of writing it as a point with the angle brackets 3, 2, we can say it's 3i plus 2j. So it's 3 in the x and 2 in the y, which is the same as 3 in the x and 2 in the y. So let's let vector v be 3i minus 4j, and w is 2i plus 9j. Find 2v plus w. So it's 2v, vector v is 3i minus 4j, and w is 2i plus 9j. And so this is often favored in science and engineering because you don't have to know anything special really about vectors to use it. So 2 times 3 is 6. I'm just going to distribute. And then collect like terms. So I have 6i and 2i is 8i. Then I have negative 8j plus 9j, which would be 1j. So it's 8i plus j. That's all there is for today. Have a good day.